Hi, welcome to this video on Scalar Product from the vectors topic of higher maths. What we're going to look at today is very simply how to calculate the scalar product of two vectors. Now, the scalar product is a way of multiplying two things together, and it's, as the name suggests, it doesn't produce a vector, it produces a scalar number, as in it just produces a value. It's a formula that we use, that you get on the formula sheet. Okay, it's this one here in the yellow box, A dot B, which is the notation for scalar product, is equal to the magnitude of A multiplied by the magnitude of B and multiplied by the cosine of the angle between those two vectors. Okay, now a couple of important points. The angle between the two vectors is obviously going to be one that is less than 180. And this is the kind of one you have to be careful of. The two vectors must point away from each other. So both vectors must leave the meeting point in order to calculate or to be able to calculate the scalar product. Okay, there's one that can go in your notes for you. I'm just going to give you two quick examples and leave you to do the practice then in class. Okay, so copy that for me now and then we'll move on. Thank you. Okay, there's two examples there. Calculate A dot B for each pair of vectors. Let's look at this first. Have a wee try at it and then I'll go over it after. Okay, so first thing we should be writing down here is that A dot B is equal to the magnitude of A multiplied by the magnitude of B times cos of the angle in between. Okay, so here that magnitude of A is 5 multiplied by 7 multiplied by cos 45. 5 7s are 35, cos 45 is 1 over root 2 from our exact values. So there, your scalar product is going to be 35 over root 2. Okay, now it's just as simple as using other formulas is on the formula sheet. You have to understand what it is and understand how to use it. Okay, and question 2 there is a little bit trickier. Okay, because both vectors are not leaving that meeting point. Okay, one is traveling away from, but vector B is traveling towards. So what we're going to do is we're going to create an image there of vector B. We're going to move that up there so that both vectors are leaving. Okay, so this one there, that is vector B. We're just going to move that up to the top. So the magnitude doesn't change, but that angle there will. Okay, so pi over 6 is 30 degrees. So really in there, that's going to be 150 or 5 pi over 6 is the angle in there that we need to use. And that's where people make mistakes that's where a lot of mistakes are made rather. Okay, now the formula is going to be exactly the same. We're using A dot B is equal to magnitude A, magnitude B cos theta. So it's 2 multiplied by 4 cos 5 pi over 6. Okay, now I'm going to do a little bit of working at the side here. Let's do cos of 5 pi over 6. Well, 5 pi over 6 is 150. So I know that's going to be in the second quadrant where cos is negative. So cos 5 pi over 6 is the same as negative cos, and that is 30 degrees back, or negative cos 30, which is, excuse me, sorry, which is negative root 3 over 2. Negative root 3 over 2. Okay, so that now becomes 8 times negative root 3 over 2. So it'll be negative 4 root 3 when you do the 8 divided by the 2. Okay, so that's where your kind of tricks are coming in there. Making sure you can move your vectors to ensure they both leave the same point, and then calculating exact values. Perhaps there's a non-calculator paper. That's just another wee thing that can come in there. Okay, but big thing to remember, that's your formula using the magnitudes, multiplying by the cos theta, and make sure the vectors are pointing away from each other. Thank you.